So good evening to everyone. We will be starting in 5 to 10 minutes. We'll wait for other people to join. Okay. So in the meantime, if you have any questions of previous classes, you can ask. Otherwise, we'll just wait for a couple of minutes for people to join. Okay.
So I hope I'm audible to everybody. Everybody can hear me, and I also hope that you're able to see my screen. Can anybody confirm? Okay, thanks. So we will be starting in 10 minutes, 5 minutes. Okay. So anybody of you have any doubts? Okay, then we'll be starting. I will start with the first question. Yes. So first of all, I welcome you all to this week 7 lecture of NPTEL course, Thermodynamics of Fluid Equilibria. Myself, Varad Dow, I am a doctoral student in the Department of Chemical Engineering, IIT Kanpur, and I'm also a PMRF fellow. So I would like to first of all thank the NPTEL team for allowing me to teach this thing uh, on this NPTEL course, and I'll just wait for a couple of minutes if anybody has any doubts or anybody is unable to hear me or unable to uh, see my screen. You can just message in the you can either unmute yourself and tell, or you can message in the chat box. Okay. Yeah, so everybody is able to hear me. Okay, then we'll be moving on to the first question. Okay, so first question for this week is the approximate value of fugacity of a gas. Okay, so this is the fugacity of gas. Now we don't care whether it's a real gas or ideal gas, but it's just that they have mentioned that approximate value of fugacity of a gas from its pressure and molar volume is given by this relationship. Okay, so this is the relationship by which the fugacity of gas is given, where F is the fugacity, V is the molar volume, P is the pressure, R is the universal gas constant, and T is the temperature. Okay, okay, is mentioned the density of gaseous ammonia. Okay, so this gas is ammonia gas. Okay, at so what we are given is the density of this gas, which is nothing but ammonia, at 473 Kelvin, and 50 bar is 24.3 kg per meter cube. Right. So what we want to find is estimate the fugacity. Okay. So what basically we are given? We are given expression for fugacity, which is this one. F is equals to V into P square divided by R into T, where V is the molar volume, P is the pressure, R is the universal gas constant, and T is the temperature. And we are also given that temperature is 473 Kelvin, right? And the pressure is 50 bar, right? Okay. And molar volume has been given as not molar volume, mass volume. Okay. Density, mass density has been given as 23 kg per meter cube. Okay. So mass density, that is nothing but density. Let us say it's V, capital V. Okay. What we are asked to find is what is the value of figure. Okay. Temperature. So I hope the question is clear to everyone. If question is unclear, you can ask. For those who are clear with the question, can try to solve it. Okay. I'll give you a couple of minutes to solve and try. So the options which we have is this 44.47 bar, 40.23 bar, 34.56 bar, and 76.5 bar. So I'll give you a couple of minutes. Solve it. Anybody has any answer? Okay, so anybody has any answer? So now I'm sharing the correct answer. The correct answer is option A. Okay. Correct answer is option A, 44.47 bar. Anybody got it? Okay, so let us try to solve it. So what we are given is, we are given, okay, remember we are given the mass density, right? Kg per meter cube, and what we need in here is molar volume. So it should be mole per kg or mole per gram or kilomole per kg, like this, right? So first we need to convert this kg per meter cube to mole per gram, right? Molar volume, molar density, right? Okay, so we know that rho, which is nothing but 1 by V, is nothing but this thing, right? 24.3 kg per meter. We know also know the temperature. We also know that pressure has been given to us 50 bar. We also know that as the gas has been mentioned, ammonia. We know the chemical formula for ammonia, that is NH3, and the molar weight of nitrogen is 40, and molar weight of hydrogen is 1. So 3H it will be plus 3, right? So we know the molar weight of nitrogen is 17, right? 17 gram per mole. So using this information, we will be first converting density, mass density to molar density, and then we will be substituting into this formula, right? So when we put it in here, so this will represents the molar volume, right? This is the pressure. So so these are the units, meter cube per kilomole of this, and the unit of this thing is Pascal, right? Pascal is nothing but Newton per meter square, divided by R, which is 8.314, and temperature, which has been given as 473 Kelvin, right? So we just substitute the known values into this equation, which simplifies to this, right? When we put the values, we get 44.774 into 10 to the power minus 5 Newton per meter square, which is what? Newton per meter square is nothing but Pascal, right? And we know that 1 bar is nothing but 10 to the power 5 pascals, right? Using this, we get molar volume as 44.7 bar, right? It should be, I think, plus, right? So hence the answer is 44.47 bar, right? Which is option A. So anybody has any doubt? So I'll give you, so if anybody has any doubt, they can ask, or else if anybody wants to write, I'll give a couple of minutes for you to write, okay? Okay, so nobody has any doubt. So we'll move on to the next question, okay? So the next question is this. Yeah. Calculate the fugacity. Here also we are asked to calculate fugacity. However, in earlier question we calculated the fugacity of gas, whereas here we have to calculate the fugacity of liquid. Okay, calculate the fugacity of liquid water at temperature has been given 303 Kelvin. Pressure has been given as 10 bar. If the saturation pressure at 303 Kelvin is 4.241 kilopascal. Okay, so we are given saturation pressure at temperature is equal to 303 Kelvin is nothing but 4.241, right? kPa, right? We are also given the specific volume of the liquid water is specific volume of liquid water at temperature is equals to 303 Kelvin is nothing but this value, right? Is nothing but 1.004 into 10 raised to power minus 3 meter cube per kg. And what we are asked to find is we are asked to get fugacity of liquid. Okay, the options are option A 0.042, option B 0.011, option C 0.020, and option D 0.009. Okay. I hope the question is clear to everyone. If you have any doubt, you can ask. Otherwise, I'll give a couple of minutes for you to solve. Okay. Anybody got the answer? Wait for a couple of more minutes. So I'll give you the correct answer now, and then again I'll wait for a couple of minutes. Okay. So the correct answer is option A. Okay. 0.042. Anybody got the answer? No, I wait for a couple of minutes. So anybody got it? So I'll be sharing the solution. Okay. Right. The correct answer is option A, which is 0.04. Right. Bar. Right. Okay. So what we are given? We are given the molar volume, right? We are given the specific volume of liquid water is 1.004 into 10 to the power minus 3 meter cube per kg. Okay. So here it's to be 3. So we just convert this meter cube per kg to meter cube per mole. So how it is like? So it should be like so which will be 1.004 into 10 raised to power minus 3 multiplied by molar volume of water. We know molar volume of water is 18 gram per mole, right? So when we convert it into kg, it will be 10 raised to power minus 3. So this whole quantity will be nothing but 1.004 into 18 into 10 raised to power minus 6, right? Which is nothing but this. And its unit will be meter cube per mole, right? So now what we assume? We assume that vapor behaves as an ideal gas, and then we have PSAT. We are also given the saturation pressure at 303 Kelvin is this 4.241 kilopascal, right? So when we convert it into bar, we get 0.04 24 bar, which is nothing but F set, right? So we know this expression, right? And ln of F by F set is nothing but V by RT multiplied by P minus P set. So we substitute the known values. We know V. We just calculated, right? This one. RHS value we know. So this is the value of R. This is the value of temperature. This is P minus P set multiplied by. So we are taking in kilopascal in bar, right? Then we calculate the RHS and then we know ln by. So it has to be right P set, right? So ln by this should be P set, right? Not F set but P set, right? So ln F by P set is nothing but this value. So when so this expression comes out to be 7.1435 into 10 to the power minus 3. Then we take the, so basically ln F by F set, ln F by P set is nothing but it. Then we take the exponential on both the sides. So we get F by P set. F by P set is nothing but e to the power 7.1435 into 10 raised to the power minus 3, right? That means F is nothing but P set, which we know, which is nothing but this value 0.0424 into 10 to the power minus 5 bar multiplied by this e to the power 7.1435 into 10 raised to the power minus 6, right? Which comes out to be this one 0.042 bar, right? Hence the answer is option A. Anybody has any doubt? If anybody has any doubt, they can ask. Otherwise, if anybody wants to write, I'll give a couple of minutes for you to write. So we'll move on to the next question. So next question is a theoretical question. Okay. So what we are asked, the fugacity of a liquid or a solid is approximately equals to its vapor pressure. If vapor pressure is low, the fugacity of vapor will be equal to vapor pressure, whether it's option A, option B, which is vapor pressure is not very high, the fugacity of liquid will be equal to vapor pressure, or option C, vapor pressure is not very high, the fugacity of vapor will be greater than vapor pressure, or option D, none of the above. So what we have fill in the blanks type of question. So which of the following options A, B, C, D fit in this category? The question is fugacity of a liquid or a solid is approximately equal to vapor pressure if. So I'll give you a couple of minutes for to attempt it. If anybody has any doubt, they can ask. So anybody got any answer? So it's a theoretical question, right? I'll give you the answer. The correct answer is option B, right? So the fugacity of a liquid or solid is approximately equal to vapor pressure if the vapor pressure is not very high, right? If the vapor pressure is not any high, then only this is true, right? So correct answer is option B. So the hint which I will like to give is you can understand this pointing factor, right? If you look at its definition and the meaning for which this stands for, you can find the answer for this, right? So we'll move on to the next question. The next question is this: an experimental determination of a vapor liquid equilibrium state of ether. So ether is component 1 and acetone. The more volatile is ether and less volatile is acetone. So we have a binary mixture. Okay. With the x1, so 1 stands for ether. So this is the mole fraction of ether in liquid phase is nothing but 0.3 at this conditions of temperature, and the corresponding vapor composition of acetone is 0.42 at this pressure. Okay, so what we are given is the saturation vapor pressure of pure components at the same conditions of temperature are, for ether saturation pressure is this 1.21 into 10 to the power 5 pascals, and for acetone it is 0.56 into 10 to the power 5 pascals. So assuming the ideal state for vapor phase, calculate the excess gives free energy for the liquid phase. Okay, so we have a VLE question, okay, in which one is ether, which is more volatile component. Okay, 2 is acetone, right? And the temperature has been given to us as 40 degrees centigrade, right? Total pressure PT has been given to us as 10 to the power 5 pascals. Okay, then what we are given is x1 mole fraction of acetone in liquid phase is 0.3, and y2 also we are given, it's 0.42. Then in additionally we are also given, I'll be writing here P1s is nothing but 1.21 into 10 to the power 5 Pascal, right? And P2s has been given as 0.56 into 10 to the power 5 Pascal, right? And what we are asked to find is, we are asked to find excess viscous energy of liquid phase, right? Which is what? Assuming that the vapor is ideal. Okay. So I'll give you a couple of minutes. I hope the question is clear to everyone. If you have any doubt, you can ask. Otherwise, so options are this: 0.23, 0.18, 0.43, or 0.33. So I'll give you a couple of minutes to try the question. Okay. So anybody got any answer? Right. So I'll give you the correct answer. The correct answer is option B. Okay. 0.1. Okay. So G by hat is this, right? So what we are given is, we know this relationship, right? That YIPT, the partial pressure of for vapor liquid equilibria, the fugacity of gas, fugacity of component I in the vapor phase should be equals to fugacity of component I in the vapor liquid phase, right? So this is the fugacity of component in vapor phase, and this is the fugacity of component in ideal in liquid phase. As the our vapor phase is ideal, we are not adding the phi, right? So its fugacity is given by this, and as our liquid is non-ideal, we are using this expression, sir, right? So YIPT is equals to XI PSat into gamma I, where gamma I is the activity coefficient, right? So we write for component one. So instead of I, we put one. So what we can write is Y1 PT is equals to X1 P1 sat into gamma 1. Okay, so but we know that it's a binary, so Y2, Y1 is nothing but 1 minus Y1, right? And we know y2, so we just calculate. So y1 will be 1 minus this y2, right? So we just this is the value of our y1, right? And total pressure has been given as 10 to the power 5 Pascal. Okay, so this is pt. Okay, this should be equals to x1. So x1 we are given as 0.3. This is x1, right, into p1 sat, right? So this is p1 sat. We know that p1 sat is this, right? 1.21 10 to the power 5 Pascal, right? So this is p1 sat, right, into gamma 1. So gamma 1 we need to find in order to find the excess display energy. So rearranging, we get gamma 1 as 1.07. Similarly, right? Similarly, we find gamma 2 as well, right? In a similar fashion, we find gamma 2, and gamma 2 comes out to be, right, 1.6. 1.6. So then we know this expression that GE by RT is nothing but x1 ln gamma 1 plus x2 ln gamma 2. We know value of x2. We know the value of x1, right? We know the value of x1, and x2 will be 1 minus x1, right? So using this expression, we put the known values into this expression, and we find that g is nothing but g by t is nothing but 0.18. And this is what is asked, right? The correct answer is option 18. Okay, I hope the question is clear to everyone. If anybody has any doubt, they can ask. If else, if anybody wants to write it down, I'll give a couple of minutes for you to write down. Okay, so if you have any no questions, we'll move on to the next question. So next question is this. So what we are given? We are given a methanol water vapor liquid system is at equilibrium at 60 degree centigrade and total pressure of 60 kilopascal. The mole fraction of methanol in liquid is denoted by x1, and it is equal to 0.6. And in vapor phase, the mole fraction is 0.8, right? One denotes methanol, whereas two will denote water. Okay. So what we are given, vapor pressure of methanol and water at temperature of 60 degree centigrade are 85 kilopascal and 20 kilopascal respectively, right? So assuming vapor phase to be an ideal gas mixture, what is the activity coefficient of water in liquid phase? Okay, so what we are asked to find is gamma 2, because one represents methanol and two represents water, right? So what we are asked to find, gamma 2. So if you, so the hint which I would like to give is, in the previous question we had this expression, right? So using similar kind of a equation, we will be able to solve this question as well. So what we are asked is gamma 2, and the options are option A is 0.0, option B is 0.5, option C is 1, and option D is 1.5. Okay, I hope the question is clear to everyone. I'll give a couple of minutes for you to solve. Okay. Okay, so anybody got any answer? Okay, so the correct answer is option. Correct answer is option D, 1.5, right? So we will be using the law which I use is called as Raoult's law, modified Raoult's law. Okay, because vapor phase is ideal. So we are using it for component 2. So this is Y2PT is equals to gamma 2 X2 into P2 set, and what we need is gamma 2, right? So we rearrange, we get gamma 2 is equals to Y2PT divided by X2 P2 set, and we put in the known values. So we are given, right, x1 has been given and y1 has been given. As it is binary component, we can write x2 as 1 minus x1 and y2 as 1 minus x 1 minus y2, right? So this, and we already know what is the total pressure. Total pressure has been given as 60 kPa, and total P2 set has been given as 20 kilopascal, right? So we put in the values into this expression and we get y2 as 1.5, right? Hence the answer is option D. So I hope the question is clear to everyone. If you have any doubt, you can answer. You can ask. Otherwise, we'll move on to the next question. For those who do not have any answer, do not have any questions, they can try solving the next question. Right. So here, what we need is Gibbs free energy, excess Gibbs free energy. Okay, in joule per mole. So those of you have any doubt in question 5, they can ask, and rest can go for question 6. Okay. I'll wait for a couple of minutes. Okay. So nobody has any questions. Okay. You can go then move on to this question. What we need is Gibbs energy. Okay. So remember this expression that G by RT is nothing but x1 ln of gamma 1 plus x2 ln of gamma 2. Right? We already calculated what is the value of gamma 2. In a similar fashion, we can calculate the value of gamma 1 and the x1, x2 are already known. Because in this expression, you can find the G by RT, right? So I'll give you a couple of minutes for you to try. And these are the options, right? Okay. Right. So in a similar fashion, we calculate the gamma 1. Gamma 1 comes out to be 0.94. And using the similar expression, we calculate G by RT is x1 ln gamma 1 plus x2 ln gamma 2. Hence, we rearrange, we get G is equals to RT into x1 ln gamma 1 plus x2 ln gamma 2. And using we put in the known values into this expression, and then we get G is nothing but 346.24, which is nothing but 346, right? Hence, the correct answer is option C. Right? If you have any doubt, you can ask. Otherwise, you can move on to the next question. Right? Question number 7. I'll give a couple of minutes. So question number 7 is a theoretical question, which is which of the following system would be captured well by Van-Laar model? Okay. So in order to answer this question, you should be knowing what is the Van-Laar model, right? I'll wait for a couple of minutes. Okay. The correct answer is option C. Okay. Both of them are right. Okay. So we'll move on to the next question. Next question is this one. Question number 8. So what we are going mode fraction and activity coefficient of component 1 in a binary liquid mixture are x1 and gamma 1. G is the excess molar gives free energy of mixture. R is the universal gas constant. And T is the absolute temperature of the mixture. Which of the following is always right? So I'll give a couple of minutes for you to solve. Okay. So the hint which I would like to give is again the same formula, which is G by RT is nothing but what? X1 ln gamma 1 plus X2 ln gamma 2. Okay. So using this expression, so just you take limit on both the sides. Limit x1 tending to 1. So what does this mean? Okay. So I'll give a couple of minutes for to solve. Okay. So as x1, so the correct answer is option A. The explanation for this is, we'll move here. So we know that G bar T is summation xi ln xi, which is nothing but this. As x1 tends to 1, what does that mean? For binary mixture, this means x2 tending to 0, right? That means this term goes to 0, right? Right? So that means, and x1 is anyways going to 1. So this is nothing but gamma 1. But what is going to be gamma 1? Gamma 1 is going to be 0. Why? Because as x1 tending to 1, that means we are going to a perfect pure component 1. That means it is going to be pure liquid, right? For pure substance, x1 is nothing but 1, and gamma is also going to 1, right? Because see, you have a binary mixture, and in a binary mixture, when you increase the mole fraction of one component, let's say one component is very excess as compared to other, mole fraction of first one component is very close to 1, that means it's a pure species. And for pure species, the activity coefficient is going to be 1, right? Which is just logical, right? So this is nothing but, oh sorry, this is not right. It's going to be 1. It's going to be 0, right? Gamma is going to be 1, right? Okay, so let me just write it in a elaborate way. Okay. Okay, so we know this expression, right? Then we take limit on both the sides. Okay, when we take limit x1 tending to 1, that means x2 tending to 0, right? Which is nothing but x1. So x1 is 1 into ln of gamma 1, right? Plus x2 is anyway 0, so this is going to be 0. And as x1 tends to 1, that means gamma 1 is tending to 1, right? So that means this is nothing but ln of 1, which is nothing but 0, right? This is what has been mentioned. Okay, hence when x1 tending to 1, limit x1 tending to 1, g bar t is nothing but going to be 0, because ln of 1 is going to be 0, right? I hope the question is clear to everyone. If you have any doubt, you can ask. Otherwise, you can go ahead with the question now. Okay. So I'll wait for a couple of minutes for you to solve. If anybody has any doubt, they can ask. Otherwise, those who do not have any doubt, they can go to question number 9. Okay. Okay. So we'll move on to the next question. So the next question is, vapor pressure for pure substance at a temperature T is 30 bar. Okay. The actual and ideal gas values of G bar RT for saturated vapor at this temperature T and 30 bar are 7 and 7.5 respectively. Here G stands for molar gas free energy, and R is the universal gas mass. The fugacity of the saturated liquid is what we are asked to find. Okay. So these are the options. Okay. So I'll give a couple of minutes for you to solve. Okay. The correct answer is option A, 14.9. So what we are given is G by RT is 7 and G by RT of ideal gas is 7.6. So we know that phi x is nothing but Fi by P, which is nothing but e to the power gr by RT, where gr by RT is equal to G by RT minus G by RT of ideal gas, right? So we know using this thing, we get gr by RT. So residual gives me energy divided by RT is nothing but minus 0.07. Huh? Then we just put it, we know this expression, we put the known values into this expression. Gr by RT we just calculated 0.07 and we rearrange this equation. It comes out to be fugacity is nothing but 30 into e to the power minus 0.7, which comes out to be 14.9 bar, right? Hence the correct answer is option A. Okay, so I'll give couple of minutes. If you have any doubts, you can ask. Otherwise, if you want to write, you can write. So I'll give you a couple of minutes for that. Right. So we'll move on to the next question. So the next question number 10 and 12. The data is common for question 10 and 12. Okay. So what data have we have given? We are given a methanol water vapor liquid equilibrium system is at equilibrium at 60 degrees centigrade and 60 kilopascal. The mole fraction of methanol in liquid is 0.5 and in the vapor phase is 0.8. The vapor pressure of methanol and water at this temperature are 85 kilopascal and 20 kilopascal respectively. Assume that the vapor phase is an ideal gas. What we are asked to find is what is the activity coefficient of water in liquid phase. So I'll give a couple of minutes for you to solve. So correct answer is option B, 1.2. Anybody got it? I'll give you a couple of minutes for you to try. So what we have is for water, VLE between ideal vapor mixture and non-ideal solution. So we know YIPT is equals to XI, PSI into gamma I. So for here I, we are writing for water. Hence, so we put in the known values, right? We know that mole fraction of water is in vapor phase is 0.2. Total pressure is 60 kPa, right? From these values, right? And what we need to find is activity coefficient of water, right? Liquid water. And we also know that mole fraction of water in liquid phase is 0.5 and saturation pressure of water at mixture conditions is 20 kilopascal, right? Using this expression, we put in the known values and we find that mole fraction, activity coefficient of water in liquid phase is 1.2, right? So that is what we asked. In the next question, what we are asked is what is the activity coefficient of methane? Okay, in a similar terms, you can try, you can find question number 11 as well. So I'll give a couple of minutes for you to try. Yeah. So in a similar fashion, for methanol, VLE between ideal vapor mixture and non-ideal solution. Okay, that will be YMPT is equal to YMXM set. We put in the known values into this expression, we get activity coefficient of methanol in liquid phase is nothing but 1.13, which is option 2. Okay, so those of you who have any doubt in this question can ask. Else you can move on to the question number 12. Okay. Right. The correct answer is option C. Right. We know that G by it is nothing but summation xi ln gamma I, as we know x1 x2 and gamma 1 gamma 2. Right. For our system, we can write G by it is nothing but xw into ln of gamma w plus xm into ln of gamma m. Hence, we rearrange it and we get G is nothing but RT summation xi ln xi. We put in the known values, right? And we get G nothing but 420.340 per mole, which is nothing but the closest value in option is 422 joule per mole. Okay. I hope the question is clear to everyone. I'll wait for a couple of minutes if anybody has any doubts. Okay, then we'll move on to the next question. But before that, I hope we can take a 5 minutes of break. If you have any doubt in the question still now, you can ask. Okay, then we'll move on to the next question. So next question is also combined question. It's for question from question number 13 to question number 17. Okay. What we are given is figure A represents the Px and Py plot for binary mixture, and figure B represents the plots of 4 different properties of liquid phase mole fraction for the same binary mixture. The notations used are xi is nothing but mole fraction of component I in liquid phase. Gamma is mole fraction of component I in vapor phase. P is the total pressure in kilopascal. T is the temperature in Kelvin. Gamma is the activity coefficient of component I. R is the universal gas constant. G is the molar Gibbs free energy. So based on figures A and B, we have to answer the following questions. Okay. So these are the figures. This is Px and Py plot. This is figure A. This is figure B, which is nothing but property of mole fraction. Okay. So what we need to find is A, B, C, D. So choose the correct option for the binary mixture. Okay. So based on this figure, what we need to find is we have to choose the best option. So option A is whether the mixture is ideal. Mixture shows positive deviation from Lord's law. Mixture C shows negative deviation from Lord's law. Insufficient information. Okay. I'll wait for a couple of minutes. Okay. So in order to answer this question, it's a theoretical question. You have to understand what is the ideal, what is the Raoult's law. If you have clarity on what Raoult's law stands for, then you will be able to answer the question, right? So the correct answer is option B. Okay. The mixture shows positive deviation from Raoult's law. Okay. We'll move on to the next question. As this is a theoretical question, if you have any doubt, you can ask. Okay, then we'll move on to the question number 14. Okay. So which property is represented by curve in figure B? Right. So in this figure, what is the value of B? Right. Okay, then options are this G by RT versus X1. So x-axis is X1 and y-axis we want to find which is G by RT or ln gamma 1 or G by RT into X1, X2 or ln gamma 2. So I'll give a couple of minutes for you to solve. Okay. So correct answer is option B. Okay. Now why is that? We know that limit x1 tending to 0 ln gamma 1 is nothing but ln gamma 1 infinity, which is nothing but some positive constant, and limit x1 tending to 1 ln gamma 1 is nothing but ln of 1, which is nothing but 0. So you see here it is coming so this it is coming out to be 0, and here at the limit it's coming out to be some positive quantity, right? Ln gamma 1 infinity, right? Hence we can say that this is B. Okay. Now the next question would be, right, curve, oh sorry, right? So in the subsequent question, so what we are basically trying to find is what is this ABCD, right? So this is A, this is D, this is B, this is C. So we found that A stands for ln gamma 1 versus x1, right? Similarly, try to find what is the value of what is the y-axis for curve B, what is the y-axis for curve C, and what is the y-axis for curve D, right? And the options are going to be this, right? Now try to find. I'll give you a couple of minutes for you to figure it out. Okay, so correct answer is option figure A stands for ln gamma 1 by x1 because of this. So curve B represents which? It represents option D, ln gamma 2 by x1. Right? Why? Because limit x1 tending to 1, ln gamma 2 is nothing but ln gamma to infinity, which is nothing but some positive constant, and also ln gamma 2 as x1 tending to 0 is ln of 1, which is nothing but 0. Hence, curve D follows this trend. Hence, option D is correct. For curve C, the answer is option A. Okay. Now, why is that? Because we know that G by it is nothing but summation x1 ln xi, summation xi ln xi, which is nothing but for binary mixture x1 ln gamma 1 plus x2 ln gamma 2. Clearly, limit x1 tending to 1, G by it is 0, and limit x1 tending to 0, ln of G by it is nothing but ln of 1, which is 0. And curve C follows this trend. Hence, option C is correct. Right? I hope the questions are questions and also the solutions for all the questions is clear to everyone. And if you have any doubts for this session or any sessions till now, you can ask. I'll wait for a couple of minutes. And for those who don't have any doubts, they can wait. Okay. So I'll wait for a couple of minutes if you have any doubts. Okay, nobody has any doubts. So I think we can stop our session. And I hope to see you in the. So thanks for attending this session, and I hope to see you in the next session. Okay. We'll be ending. Okay.